So we're in the middle of our 71 Cutlass build, and this car is getting to be kind of complex because we've got a Bullseye Power 75mm turbo. And I don't know if you've noticed, but you can't go to your local speed shop and buy a turbocharger kit for an Oldsmobile powered anything, basically. So we were charged with fabricating all the mounts for the turbo and the exhaust plumbing and the intercooler and all that jazz. And here's how we approached all that. Now, to make the turbo mount in the car, Brett Evans from Outlaw Turbo Motorsports came up with this stand idea.
Here's our original bracket that we started with to mount the turbo off of. It's needed some modification, and this was just to hold the turbo in place just so we can get a good idea where it needs to be. I'm going to use this base still, and what I've done is I've made this little bracket. It's going to look like this. I need to cut it and still do some bending on it. But this way, this piece is going to be like this. So I need to move the turbo over to get away from the alternator. And then we thought about putting this curve in it. So when this piece gets welded on, it looks right instead of on some angle, 45-degree angle. So we'll put the sides on it, and then once I get it in the car, I'll find out on the other side what I need to do, because I need the tube that's actually going to feed the turbo to go inside here somehow.
Once he got the base roughed in, he added the T6 turbo flange to it and cut an opening in the side and made a tube that goes into the base.
Okay, here's our little frame mount. This is going to sit on the frame, and then it slides right in like this. So this will be all welded together. We're going to put a V-band, we're going to cut it in here somewhere. Just put a V-band here that we can come in with our crossover tube and tie into this.
He spent some time to, weld it up clean and grind it so it's a nice free-flowing design.
We're in the process of doing another test fit, and we're looking at these plastic inner fender wells. And it looks like we're going to have to cut them and make some kind of heat shield. But this is going to need to slide back a little bit. So I need to trim that panel first so we can actually get this in there right.
You got to consider packaging at every step of the way because the hood's got to close, all the rest of the accessories have to fit on the car, so it's a little bit tricky. So you got to keep going back to the car and holding stuff up and checking to see that it fits. The factory inner fenders are plastic on this car, and the turbo was actually touching that inner fender well, so we cut it away to make room, knowing that later on we're going to have to fabricate a steel heat shield and conform it to fit around the turbo without getting in the way of the tire. We're getting the exhaust out of our engine through the manifolds. The driver's side goes underneath the engine and then meets the passenger side manifold where there was a factory cast-in boss to connect the two, because Oldsmobile used that passenger manifold as a Y-pipe in the single exhaust cars. So we're just going to use that to connect the two together. The exhaust then leaves that passenger side manifold, loops underneath the car through some mandrel bent tubing, and joins into the turbo inlet pipe with a V-band clamp joint. And the next challenge is to get the spent exhaust gas out of the turbo and out of the car. And for this, Brett came up with a pretty trick idea. He ended up using a cone. The turbo exhaust is like a 5-inch diameter. So he got a 45-degree 5-inch tube and then welded this cone onto it. And the cone goes from 5 inches down to 3 inches. And at the end of the cone, it dips below the car where it's going to meet up with our 3-inch MagnaFlow exhaust kit. And here, we only have one exhaust coming off the turbo system, but we got a dual exhaust MagnaFlow kit with an X pipe. And we thought this was kind of a neat way to go because we simply removed the other inlet side of the X. and basically turned into a high-flow mandrel bent stainless Y pipe. So it still has the singular input that it needs, but then it goes through 2 mufflers and then out the stock dual exhaust locations in the back of the car. The next phase is what we're going to call the cold side of our turbo system, which is the ambient outside air that's going to get drawn into the turbo and compressed on the compressor side, and it's got to make its way out of the turbo, through an intercooler, and then into the engine. So the nice thing about a turbo is you can rotate the 2 housings and point the turbo compressor housing outlet anywhere you need it to go. So we've got our turbo mounted up on the stand and started to look and see where things were going to exit. And because of our intercooler, we had to run this out the front of the car, across the front of the car, back into the driver's side, and then up into the engine. So the intercooler is there to act as an air-to-air heat exchanger. We chose the biggest one we could fit in the car. It's made by Bell Intercoolers, and it's like 17.5 by 24 inches. It's a 4.5 inch thick core. We originally wanted the inlet and the outlet on the top side of the intercooler, but once we got into the project, we found that for packaging reasons, turning that intercooler upside down and having the inlet and the outlet on the bottom made it easier to make tubing to come out of the turbo and go into the intercooler, out of the cooler, back into the car. Once we got the packaging down a little bit better, Brett began the installation of the TurboSmart ProGate 50 wastegate. And the wastegate is installed on the exhaust side, and it's basically a valve. A port on one side of the wastegate senses boost pressure, and when it overcomes the spring, the wastegate releases extra exhaust pressure to keep the system from overboosting. You can change the spring inside of it to allow for a higher level of boost or a lower level of boost. And I think it comes with a couple different springs, from the factory. You'll notice the orientation of that wastegate in the exhaust path. You want to make sure that when it opens, it dumps smoothly right back into the exhaust. And you also want to make sure that your exhaust flow goes smoothly into that wastegate so that you don't have any weird pressure problems. So airflow and system design is crucial. To make all the tubing to connect the turbo to the intercooler and the intercooler to the air inlet on the engine, we used a whole bunch of mandrel bent sections of tubing, and the pieces are TIG welded together. The stuff interconnects using silicone hose tube connectors and what are called T-clamps. It's like an exotic hose clamp, but it's got a T-shape on the end. And it's not a screw type hose clamp like a traditional. It provides a more flat compression on that silicone intermediate hose. Where the tubes come together in hard connections, we use nothing but V-band clamps. And these have a ring that welds onto each end of the tube, and then a V-shaped band clamp that goes over them that you can tighten down, and they've got a lock nut on them, and that keeps the tubes butted flush, and they don't blow out under pressure, and they don't require any gaskets. Next time we're installing the TurboSmart blow-off valve, finishing up our intake tubing all the way up to our Holly throttle body. Some of the parts get extreme powder coatings, 2200 degree ceramic high temperature coating, and then we're going to be installing all of the rest of the parts to complete our turbo system on the S71 Olds. You can learn more about this project and see additional build photos on our website at V8TVshow.com.